Welcome everybody. So in today's video, as you can see, we will do polynomial regression. So here we will learn how to combine features to improve the performance of our algorithm. For example, we can combine two features into one or multiple features into one feature. So let's begin. So to improve our algorithm, let's take an example of selling a house. So for selling a house, let's take example that we use the frontage and depth to account for the price of the house. So what I mean by that is the length and the width of the house will decide the price of the house. So here we use the hypothesis function h of theta x equals to theta 0 plus theta 1 x1 plus theta 2 x2, where x1 and x2 are frontage and depth. So to improve our algorithm, we can combine them and use a new variable x to represent the area. So it will represent the area of the house. So now we can write new algorithm as h of theta x equals to theta 0 plus theta 1 times x. So this will be our new algorithm. So now let's move on. So now let's talk about choice of features. So here we have the cost on the y-axis and the size of the house on x-axis. So here we cannot use a linear function since a straight line would not represent it as good as a curve. So the curve something like this will be better suited. So here we will use, so here our function will be theta 0 plus theta 1 x1. So this will be a linear function, but here a quadratic function may be better suited for this. So we will write theta 2 x1 square. So this will better suit a graph like this. So this will be a curve like this, but there is a slight problem here too, because as the size increase it will go downwards after some point. So but as the size of house increase, it is obvious that the cost cannot decrease. So the obvious way to solve this problem is that we can better use a cubic equation. Like we can add another variable, not another variable, another. So here we can add another feature. So this will be x1 cube. So now it will just increase, not decrease. So if not increase, it will maybe remain constant. So that's okay, because the cost can decrease but it may remain same. So that's our way of solving this problem. So here we can just use another method, that we can assign x equals to x1 and then y equals to x1 square and maybe z equals to x1 cube, or you may use any other variable like x1 equals to x2 equals to x1, x3 equals to x1 square, and x4 maybe equals to x1 cube. So that's how you can represent them. Now what this will do, this will make it in a form of linear form. The maximum power will be here 1, not 3 or 2. That will make computation easier and easy to understand. Not much difference here. And if we are using the quadratic equations, we must definitely use the feature scaling without mean normalization, because feature scaling will be good enough and more than good. So what we can do is, if we say its value is maybe 1000 feet square, so the size is 1000. So this will be, let's take from 1 to 1000. So its value will be from 1 to up to 10 to the power 6. So that will be a huge value. And here what we can do, its value will be a lot higher than the previous one. So its value will be 10 to the power 9. That's a lot than expected. So what we shall do, the simple way is divide the whole thing by 1000. The maximum value, whatever maybe the value of x can be 500, 600, and here we can divide by the maximum value, that is 10 to the power 6. So that will solve the problem, and its values will come out in between 0 and 1. So that will make easier to progress ahead lot faster. So that's the whole point of using feature scaling. So if you haven't watched our last video, so so you will not be able to understand that better. So please watch it before going for this one. That will be advice to who want to ace the topic. So let's move on. So this is how our choice of features will affect our whole thing. But here there is one more situation where we can use maybe a root. Maybe we can just do not use the cubic one, and we can use a root solution where we can take our features in root values, square root obviously. So what we can do is, let me just erase. Now we can do a simple task, that is, wait a minute, we can just use root x1 here instead of x1 square, because root x1 will do. You must be asking what this will change. So as you all know, x1 cannot be negative here. You must be asking why, because anything inside root will give rise to imaginary numbers, will be an imaginary number. So that's why we will take all the positive values, and so this will assure that our graph is always increasing, because all the values here will be positive ones. So this will help us maintain our graphs movement, and so that's the thing I want all of you to understand. And so here we can also use the feature scaling. So we x1 equals to 1000, so its root will be about you can say 32. That will be approx 32. So now what we can do is we can divide root x1 by 32 for feature scaling, and x1 by 1000. So that will solve our problem. So I hope all of you would understood it better. So thanks for watching, and I hope you have liked my content. And before you go on, I have just released my first book on Python. So if you want to buy it, the link in the description, that will take you to the book, and it is free up to 8th January. So go ahead and get the book for free. And if you want to support us, then you can buy it for money also. It's for $2 and available worldwide. And I have covered all basic to intermediate level, and the next book will cover the advanced level. Here you do not need the advanced level much, because that will be the basics, and intermediate will be you can say just enough for beginner level, but you need advanced for as you move on. So definitely check it out. And this is our YouTube channel. You can subscribe here, and we are just growing. We have reached 1.87k views totally, and that's great. And we have hit 158 subscribers. That's so close to 160. So like, share and subscribe, and see you in later.